Hi, I'm going to go through a couple of questions about how to solve equations with radians using CAST. Okay, so if we start off with just quite a basic one, so sine x is equal to 0.5. Now, if you were solving that using degrees, you would just use your calculator, you would press inverse sine of 0.5, and you can see that my calculator is in radians already. So let's go to setup, change that to degrees, go back to inverse sine 0.5. Okay, and it's 30 degrees. So you would find your first answer by doing inverse sine 0.5. 30 degrees. Now, what CAST does, it is of course a nice convenient way of summarising all of the informations from all of the graphs onto one diagram. That angle there, 30 degrees, we always do it attached to the x-axis. So 30 degrees is going to be there. Now, I've marked that 30 degrees in A because all sine, cos and tan are positive there. Because I'm dealing with a plus 0.5, we'd put the other angle in the positive sine quadrant. You always go from the x-axis, so that is the angle that's 30 degrees there. So you can see the first answer, 0 to 30 there, x is 30, as we had up there already, and the other one, that angle from there to there, and that of course is all of 180 minus 30, which makes that 150. So that is in degrees. Now, doing it in radians, the steps are just the same. The only thing I'm going to do different, I'm going to have a different things referring to on my graph, and I'm also going to turn my calculator to radians. I'll do that first. Shift setup, go down radians. So I'm in radian mode. So I'm going to do the same equation. Sine x is equal to 0.5. I find the first answer, inverse sine 0.5 tells me is pi over 6. Of course, this is one of the exact values, and you might well remember those, but you might as well just do it on your calculator because it can cope with exact values. You consider your CAST diagram as you did in degrees. I have got positive a pi over 6, so I'm going to draw an angle there. Now, it can be confusing because you're dealing in radians where exactly these angles lie, but of course you've got all the way around is 2 pi, so that's 0, but it's also 2 pi. So that makes this over here pi or 180 degrees. So if you're thinking, I'd still even now tend to think in radians first, 0 to 180, and then convert right 0 to pi. 2 pi is all the way around 360, so pi is 180. So if that's pi, this is pi over 2. 90 degrees, and so pi over 6 definitely goes there. So I've put my first angle in there, that is pi over 6. Because it's positive, I know there's another one here that is also pi over 6. But this time, my calculation, the first one is pi over 6. The second one, well, it's from here to here. So if I went all the way around, that would be pi, but I need to subtract that pi over 6. And just think fractions. Pi over 6, 6 pi over 6. The 6's will cancel, to give a whole pi. So 5 pi over 6. So two answers, pi over 6, 5 pi over 6, two answers, 30 and 150. Okay, let's do something a little bit more complicated though. If we had a negative, so sine x is equal to minus 0.5. In those previous questions, I didn't talk about ranges at all, but this question, this is the first in the questions kind of on that link that you sent. 0 to 2 pi is our interval there. Now, this negative's a slight problem. If you type in inverse sine of negative 0.5, I get negative pi over 6. That just makes things a little bit complicated when we're going from 0 to 2 pi. It's often easier just to ignore that negative. So what I mean by that is, if instead we solve sine x is equal to just positive 0.5, we've seen in the previous question, then that in radians gives us pi over 6. But what I'm going to do when it comes to the cast diagram, I am going to put that in the negative quadrants, okay? And we do that, of course, because we're actually dealing with a negative 0.5 there. Sine is positive there and there. It's negative here and here. And as before, we always refer to the angle attached to the x-axis. So this little acute angle here, that little triangle there, that angle is pi over 6, and similarly here, that angle is pi over 6. And then all we need to do is relate that to that particular complete cycle, that cycle in the cast diagram. I've got 0 here, my first solution all the way around, well, not all the way around, half the way around, and then that little bit. So my first answer here is halfway, remember that's pi, plus that pi over 6. 6 pi over 6 plus pi over 6, 7 pi over 6. And then I have a second solution. This one is all the way around, which is 2 pi, but just minus that pi over 6 there. 2 pi minus pi over 6. That would be 12 over 6 pi. 12 over 6 minus 1/6. 11 pi over 6. Okay, if we had one, and let's just look at the next one here. So the angle here is slightly more complicated. So I've got cos 3x equals 1 over root 2. Now, if you want, you can just kind of just do a substitution. Oh, I don't like that angle there. So let's instead work with u equaling 3x. So solve cos u equal to 1 over root 2. So you're just making that complicated angle slightly less complicated. Solve this. First stage, I am going to inverse cos 1 over root 2. So shift cos, let's get a fraction up, 1 over the square root of 2, put that bracket outside, pi over 4. If you want to do a quick little comparison, pi over 4, right, 180 is pi, so divide by 4, divide by 4. All right, that's 45 degrees. That can help to put that in the cast diagram. So, because I'm dealing with cos, I know that I've got an angle there in that quadrant. I've got another one in this quadrant because that's when cos is positive. So I have a pi over 4 in there and I have a pi over 4 in there. So that means my two solutions for u, the first one, well, it's pi over 4. The second one, if I was dealing with 0 to 2 pi, we would go 2 pi minus pi over 4. But here, the interval that we want is between negative pi and plus pi. So you either go that way, positive pi over 4, or that way, going in the, what's that, the clockwise direction, going underneath is going to be negative. So it's just simply pi over 4 and negative pi over 4. Now, crucially, these are for you. At the start, we simplified our angle by saying, okay, u is actually equal to 3x. So 3x is either pi over 4 or negative pi over 4, which means that x, if I divide pi over 4 by 3, pi over 12, negative pi over 12. We can just not bother with that substitution. Instead, you could simply say, okay, cos 3x is equal to 1 over root 2. So 3x is equal to inverse cos of 1 over root 2. Inverse cos 1 over root 2 is pi over 4. Or, so you've done your alternatives there, negative pi over 4. Those are the answers to 3x. Therefore, x is equal to pi over 4 divided by 3, or negative pi over 4 divided by 3, so plus or minus pi over 12. If we had something that was completely kind of different, so let's do a tan one. Tan of 4x minus pi over 6 is equal to negative 0.7. And let's go between 0 and 2 pi. Okay, so I won't do the substitution thing here. We'll see how it goes. I know that tan of that particularly nasty angle is equal to negative 0.7. So I know that the angle, which is the whole of that bracket, is equal to inverse tan of that. Now we've got a negative there. So what I'm going to do is I'm actually going to work out inverse tan of 0.7, and then I'm going to put that in the negative parts on my tan, on my cast diagram. So you can see that I've kind of, forgotten about that angle there. I'm just focusing in on the inverse tan stage. Shift tan 0.7 is equal to 0.61. Should we call that 0.611? 0.611. Now, 0.611, it's not an angle in terms of a fraction of pi, but it's going to lie between there and there, isn't it? Because pi over 4 is, no, that's pi over 2, isn't it? That's pi over 2, and pi over 2 is just 1.57. So it's going to be somewhere acute. However, because it's negative, I'm going to put it in the 2 negative quadrants for tan. So I've got a 0.611 there and a 0.611 there. That unit is an angle. It's a unit in radians, if you just want to put a rad there, just so you know that you have found your angle. So those are my 2 positions. I then have got my angle is equal to, so remember that's pi from there to there, pi minus 0.611, or I've got the other one here, but I need to go around in that direction, so it's going to be 2 pi minus 0.611. So we've got 2 decimal answers. Now sometimes in the previous 2 we had a fraction of pi. If you have decimals, it works exactly in the same way. It's just a bit more unsettling because you've got all these horrible decimals floating around. So I'll just go with 2.53 there, and then I've got 2 pi minus 0.611, so 5.67. Those are the two answers I get from my cast diagram, but now I've said that this is just the angle. The angle is the whole of that. So the final stage is to say that 4x minus pi over 6 is either equal to the 2.53, and then we have another answer, which is the 5.67. So we just need to do I've still got that bottom number in my calculator, so I will add pi over 6 to that. And then I would need to divide by that 4. So my first value for x, 1.55, and if I now do the same with the 2.53, add on pi over 6, and finally divide by 4, 0.76. Okay, there you go.